Good afternoon, everyone. Thanks for being here. Thanks to the organization. We are really pleased to be here in California again. My name is Pedro.Carrillo, CEO of EC2C. I have with me people representing the government of south of Spain and people representing one of the major olive oil producers. You have to know that, maybe you already know that Spain is the major olive oil producer worldwide. And we are using a lot of technology in Spain. So we are going to introduce today a specific case of using big data, open big data, and artificial intelligence to solve a huge problem in the olive crop in Spain. So let me introduce, we're gonna share the presentation, the three of us, three companies. We are four, but three companies or three institutions. So let me introduce you to Rafael Olvera, which is the General Manager for Agriculture Ministry in south of Spain, Ricardo Alarcón, which is the Head of Plant Health in Agriculture Ministry in the south of Spain, and Ramón Rivera, which is the CEO of Elaya, which is a major olive oil producer in Spain, Portugal, and Morocco. So I will give this to Rafael, and then you can switch on your slides. We're going to be introducing this case with the support of some slides, as we are going to give you some numbers and figures that is good for you to see on the screen. So Rafael, please.
Thank you, Pedro. Good evening, everybody. I would like to say, first of all, thank you to the organization for inviting to us for this conference. I would like to start with this sentence from a very famous philosopher from Andalucía. They was talking about the global world 2,000 years ago. So I will try to explain where we come and what you can find there in Andalucía. Andalucía is one of the largest region in European Union. We are in Spain, in the south of Spain, and this is the surface of our region. Is more or less or more biggest than many countries in the European Union. So many of you, I'm sure, that could know Andalucía for this reason. We have a very largest natural parks. Also, we have very famous houses. We have monuments, arts. We have a lot of golf course, we have flamenco, and we have a high quality gastronomy. Also, we have polo, we have ski station and marine. But this is Andalucía. I think that you could know it for it, but also Andalucía is this. We have a very high technology in renewable energies, mining extraction, manufacturing sector, and a very important aerospace industry. But now we are talking about tech and agriculture, and I would like to focus my conference in the agricultural sector in Andalucía. Those are the most important information about the agricultural sector in Andalucía. It's the most powerful Spanish agricultural sector. Is more or less 25% of the Spanish agricultural production. Has shown, it's very important, has shown an upward trend since 2010. It's a rich, diverse, and groundbreaking and growing sector. Those are the significant crops in Andalucía. We have many different types of crops, but we choose those to speak. Olive, orange, dehesa. Also, we have many greenhouses in the south of Andalucía, rice, berries. In this slide, I try to explain where are localized these crops. I'm going to focus on the next part of the conference in the olive sector. This is the geolocalization for the farms of olive sector in Andalucía. Just if you know, this is the river Guadalquivir, and this is the valley of the river Guadalquivir, and this is the geolocalization of the olive sector. Those are the most important information about the olive sector. We have 205 million olive trees. I think that is the largest forest from one tree in the world. We have 1.5 million hectares, more or less 32% of Andalucía. And in these crops, we have many farms with more or less 30% in organic or integrated production. So the most important thing is that 1.4 tons per year we produce of oil. This is a very important date. Almost 5 liters of 10 liters of Andalusian olive oil. More than this, more than the production, the olive sector is landscape, is biodiversity, is mitigate climate change, optimize rainwater, fix rural area population, and also oil and table olives is healthy property, have healthy properties. Of course, the product, the oil, the olive oil, has a 1,000-year tradition and is a very high quality product. We have many protected designations of origin, and we have more than 600 oil mills. Now my colleague Ricardo is going to explain about the Andalusian Phytosanitary Alert Network. Ricardo, please.
Thank you, Rafael. It's a pleasure to be here for me today in Silicon Valley Forum for explaining Andalusia Phytosanitary Alert Network. The Andalusian Phytosanitary Alert Network is a project supported with the European Agriculture Fund for Rural Development. And this is a project with the objective is to improve the knowledge in plant health for farmers, for technicians, complies the requirement for applicate to integrate pest management in Europe and also in Spain. The most important thing of the project is a collaborative project where farmers, technicians, and the regional Ministry of Agriculture work together for to be a platform on a project or to system information about pest in plant health. The project is based in biological control station. Last year, more than 5,000 biological control stations that they are points of the technician and farmer recollected data situated in biological areas, some with similar agroecological features. Phenology of the crop and status of pests as collected by the technicians. So the RIFE set us a plant health surveillance network, manages and operates the data obtained, has relevant information about incidence and intensity on plant pest and disease. So the RIFE, the RAF, is high-profile communication platform. Last year, almost 20,000 public notices and phytosanitary alerts have been made through the different channels information to the network. This is the most important channel of information to the project. It's a website, digital magazine, newsletter crops for each region, short message service for phytosanitary alerts. Sorry. So the project have two institutional profile in different social network, and have to an APP for have the information in mobile devices. The project have two crop viewer where the technician and farmer check the plant health on your crop in your biological region. And so all the things to be a big data in the project, some figures on this big data are these. So this figure gives an idea of the potential of the scope, the potential for the agriculture sector in the scope of big data, with based in a open, a public platform, big data system. There are many possibilities to apply the big data in the agriculture sector, like the example we are going to know now for applying the artificial intelligence for management of pests in the olive crop.
Maybe Ramón. En el mando.
Good afternoon. Thanks for the invitation. Okay, I'm going to present our company. We are olive oil growers, okay? And basically, we grow olive oil and olive trees in the Iberian Peninsula, in Portugal, Spain, and well, in the north of Africa, in Morocco, okay? We have, as of today, close to more than 70 farms, and we have under production already close to 30,000 acres of olive groves. Okay. We transform all our olives into olive oil, and we sell bulk. Okay, we don't bottle any oil. And our crop has a singularity that it's the olive tree is a crop that is bearing fruit in last year's growths. Okay, so every year we have we need to take care of two crops. Okay, so that's very important to understand that whatever is happening this year, whatever we are doing this year, is going to be also affecting next year's productivity, quality, and many other factors. No? So, and here is where we get into big data. No? Do we really need this? And of course we need it, because we have plenty of questions that we have no answers for them. No? And basically, in our business, we are never really happy. Either we have bad crops or we have bad prices. So at the end of the day, we really need a lot of answers to how much are we going to be producing, what qualities are we going to be producing, and also how many inputs do we really need to put in our fields. So we went into measuring everything that we could imagine, and this is where we are right now. No? We monitor and measure everything that it's around. No? We've tried plenty of sensors, images, drones, planes, satellites. Irrigation is kind of different, because technology in irrigation is very well developed and is very I mean, it's very technified already and very suited for different crops. So we get plenty of data. No? We get so many data sometimes from irrigation that is difficult to handle. And also from farm operations, every week in every farm, the phenological states are registered with images, with data. So we are getting plenty of data to analyze, although we still have many problems with data. One of our main problems is that we are pretty young. Okay? We've been doing this since 2007, and we just have an output every year that is how much do we produce. No? That is our main interest, to understand how much are we going to produce. So that's one of our main issues. Another one is that we are running or we are controlling very large-scale farms. 30,000 acres is a lot of land. And where to measure, to determine where to sample, is critical. So at the end of the day, we really have many doubts about the representativity of our sampling, of our sensors. And then we go into technology. I told you about irrigation that we thought, or we really think that is very well developed. But other technologies like NDVA, for example, for us is not very meaningful as of today, although we keep on trying. And on top of that, we generate enormous amount of data. Okay? We don't really know what to do with it, but we keep on putting data in, and hopefully someday we'll have something coming out. But still, this is where we are. No? So these are some of our challenges today. No? What should we be measuring? At what time in the year? How many times every day? So, and can we stop investing in some other things? To understand very well the interrelationships between things, especially with climate. Okay? We are very much dependent on climate. Every crop is. But ours, as I told you before, is we have like a 2-year thing going on. No? So what happened last January is affecting me this year. And I have a board, and I have to go there monthly and to try and to explain, if it was too cold or too hot, and how much it's going to be affecting next year. It's my big problem, no? At the end of the day. So well, and just 2 more things. How can we do this faster? No? And we need to pull more people in. And from the same crops, from people that are doing the same, we have to keep on putting numbers together so we can go faster. And some concern that, well, today I didn't hear much about, and that we are pretty worried, in Spain at least, is who owns the data? No? Who's going to be profiting for that? Who's going to be taking care of that? And that, for us, is also a big concern. And this is what we've been doing lately. And we are pretty sure that this is the way. We are convinced that we are in the middle, but we'll try and we'll pursue, no? And we'll get there probably soon. Thank you.
El mando. Gracias, Ramón. Well, and then, well, finally, more than moderating, I'm going to introduce EC2C. We are working together with the public administration and customers, private sector, to provide brain intelligence so that they can make decisions as users. In the case of the administration, the users are the final growers, I mean, those that have access to the information. In the case of the private sector, of course, the decision maker is the company. So we provide techniques based on artificial intelligence. So we made all these data analysis, make predictive models for them to help them to take better decisions, business decisions. Or in pest evolution, like the case of Bactrocera oleae that we are going to explain later, or productivity. It depends on which is the target to be predicted, forecasted. Then we use different databases, which are available. Or they belong to the customer, private sector, or they belong to the public sector, the administration. So as I told you, we support decisions. We help customers to take better decisions. So we have to have a business understanding. We have to understand what they need to decide and why. Then we have to then we introduce the math, which is data analysis, algorithms, and everything. But first, it's really important to understand and have a tool that is going to be custom made for a specific target, for a specific database which is available. We work with the data that is available. We are not producing data. Data is what it is. We just use that data as much as possible, that's available data. So we model, we test the model. We demonstrate that the model, the final math model, which is a completely numerical model of a complex ecosystem, which is biological ecosystem. And in the case of a pest, the ecosystem includes, of course, weather, land, the plant, and the bug, or the fly, or whatever the animal is, the insect is. So we model, we test it, and then we deliver the customer with results. And results are predictions. So the customer can see some weeks in advance what is going to happen, how that system is going to evolve. The system could be a pest risk. So the management is an integrated pest management system, and they need to know what is going to happen. Or maybe productivity. So how can we optimize irrigation and management in order to have better productivity by block, not necessarily in the whole farm, but if data are segregated, models can be segregated, and predictions also. So we use artificial intelligence technology, which is proprietary. We have been developing during the last 3 years. In the case of the RIFE, which is the red de alerta de información fitosanitaria, and in Andalucía, you saw before, it's more than almost 300 gigabytes of data, huge amount of data. So the first thing is convert that big data into smart data, and this is about data analysis. So we have that methodology to reduce the uncertainty of that much amount of data, focusing on our final target, which is to have a good prediction, in this case for the pest evolution. We include the modeling with artificial intelligence techniques, and then we have smart predictions that are delivered to customers as smart decisions, or tools to take smart decisions that are directly to business. Well, this is an example, real example of last year crop. Each dot is week, so we have been doing this for around 3 months. At the very beginning, there is no risk, there is no fly, there is no pest, but we are detecting that there is no pest, and there is gonna, in the next 4 weeks, is not gonna be pest, which is important. So if you are sure that you are not gonna be the risk, then you stay quiet. You don't use pesticides, etc. Then we send 4 weeks in advance, we send an alarm that the pest risk is going to go above the threshold, minimum threshold to apply pesticides depending on the regulation, but in this case it's 1%. 1% of olives affected. And again, we repeat the threshold at 5%, which is a serious risk, serious affection in the crop. And again, this is 4 weeks in advance. And we have an accurate system. In 1 week in advance is about 95% accuracy, and about 90% in the 3rd and 4th week. We have been doing this in 50,000 acres in south of Spain, and providing value to customers just to take better decisions for pest control, pest management, integrated pest management. We provide the results also with geolocalization, and we're using GIS, and if they are taking data from particular parcels all around the region, then we provide results for that particular area where the data is produced. So at the end, they have a pretty good system in Andalucía. I think it's unique in the world. I think it's state of the art. It's something that is really good system, but they inform up to today, they just inform what is happening on real time. They take measures and then they inform what is happening with the pest. More than 120 pests, more than 25 different crops in Andalucía. But we provide 4 weeks in advance. So we provide maps that are future risk of the evolution of the pest. So we are doing prognosis and facilitating the application of pesticides and control for that pest.